Okay, so we are super excited to be here with Ian Mitchell. And hello, Ian.
Hey there.
Morning, guys.
Hey. So, Ian is a visionary biochemist, inventor, and humanitarian whose groundbreaking innovations are redefining the boundaries of health, consciousness, and human performance. Widely recognized as a pioneer in quantum biology and advanced nutraceuticals, Ian's work spans elite collaborations, from contributing to NASA-based research to in creating life-enhancing supplements used by some of the world's top biohackers. With a genius-level mind and a heart-centered mission, Ian is the founder of Wizard Scientists, co-founder of Biocharged, and the formulator behind cutting-edge technologies like
Carbon 60 supplementation, which I'm going to ask Ian to talk about because that's one of the. No. We've been taking some of these supplements. These supplements are absolutely amazing. We'll talk about those a little bit later. And the one that Jules was just showing you, neuroregenesis, enhancing formulas.
This is a neural RX.
Yeah, it's really cool shit.
For brain repair, and also this is like a nootropic, right, Ian?
Yeah, so that one's kind of, I love that product, actually. Literally, I made it for people with Alzheimer's. That was the original intent was, and it was kind of given the context here, I'll just say it like it was. So there was this fella, he's a gastroenterologist surgeon at UCLA. But he was also a Chinese energy master and had studied in China for years and years and years. And we had a mutual friend who was a neurosurgeon from Johns Hopkins, very well respected, kind of an ace in her field. And he reached out to her and had her reach out to me, and just kind of out of the blue said, "Listen, I was told that you can knock this condition out in 3 weeks." And she's somebody that's I very much respect, and I thought, what? I don't know a damn thing about this condition. Like, that's absolutely preposterous. And it was late on a Wednesday night, like 10:17 on a Wednesday night. And I was kind of incredulous at first, but then I thought, you know what? Okay, I had been kind of working a lot on the oncology things right then, and I thought, what the hell? I'll give it a shot. It's 3 weeks, right? Maybe there's more to this kind of, energy master guy than meets the eye, and everybody touts him as being incredible. So, he's got all the credentials and all the boxes checked. What the hell? I'll give it a whirl. So I thought 3 weeks. So the first week, I kind of broke down the pathology of what is Alzheimer's. And at the end of a week, I was like, oh my God, it's not a disease. It's a protective mechanism. And that was my working hypothesis. So I kind of shifted and said, okay, if it's a protective mechanism that the body's using to do X, Y, Z, basically anytime you get any sort of environmental threat for your brain, whether it's endogenous, say like P. gingivalis in your mouth, or a bacteria in your system, or if it's something external like glyphosate or heavy metals, your brain, wraps these things in little packets, tau proteins and beta amyloids, and sequesters them. And there was already, when I kind of really broke it down, there was already sort of a precept for that physiologically. So there's this lacy band around your midsection called the omentum, OEMENTUM. And when your body's pH starts to skew, it sequesters whatever is throwing your pH off. Typically in the West, it's carbohydrates, wraps them in little fat packets and packs it around your midsection, which is why in the West, because we have so much overload on carbohydrates, everybody's midsection appears to be a little poofy and inflamed, is because it's literally kind of trying to balance that out. Because if your blood pH skews more than a couple tenths of a point, it'll kill you. And so your body, knowing that, has come up with a very nice mechanism to stop that. So the brain does a similar thing, which makes sense because it's a primary system. So when I realized that, I was like, oh, well, okay, how do I work with that? So then I started breaking down all of the component systems to what would I have to do to roll this back biologically? So that took another week. And then at the end of that week, I was like, okay, so this is my working, chemical setup, how I would mitigate all those things biochemically. So then I ordered all the compounds from all the different research labs, and everything showed up about a week later. And I had really not been tracking the time, but literally the last compound showed up at my lab and got delivered within, I don't know, maybe 4 minutes, and it was late at night, but I had gone home and it had shown up, and I brought it back to the lab, and I set the last compound down, and I thought, wait a second, how long has it been? And I pulled up my phone, and it was 10:21 p.m. 3 weeks to the day later, and I was sitting there with everything in front of me, and I was like, wow, that's a strange coincidence. And at the time, I literally, just in the mindset I was occupying at the time, my consciousness, thank God, has luckily changed a lot since then. But at the time, I thought, oh, wow, snap. That's kind of a weird coincidence. So the next morning, I got everything synthesized. And a guy that I had worked with, he had been one of my distributors in Canada for a long time. He reached out to me out of the blue and said his dad was, in his 80s, and he was in a retirement home. And he actually, I take that back. I think his dad had just turned 90. So yeah, I'll go back and double check and see how old Donald's dad was. But I believe it was 90. But he said, he's in a nursing home, he's debilitated, and he sent me a video of his dad, and he was, had a big woolly beard, and he was kind of incoherent and just babbling, nothing comprehensible, right? He was just kind of babbling on. And I thought it was so strange. And I said, Donald, yeah, I literally just synthesized a thing for this. I'll send it to you. So I made a batch of like 12 bottles, and I shipped it to him. And luckily, the base component there is a thing called caprylic acid. And so caprylic acid is it's a octanoic acid. So it's the carbonate fraction of coconut oil. So it's a medium chain triglyceride. And that's kind of hard to process for a lot of people. If you do too much coconut oil, it'll cause, GI upset. But luckily, his dad had been giving him coconut oil. So he was already spooled up. So I said, look, just hit this dose in a day and see what happens. So he started doing it, and he did it for 8 weeks, not really many changes. And then he went on vacation, and 2 weeks later, I knew he was coming back, and he starts blowing my phone up. And I'm like, oh shit, his dad's dead. That was my first thought, was like, ah. and actually now that I'm thinking about it, it was because he was 90, and I'm like, this is not good. So I call him back, and I said, hey man, what's up? And he's like, oh my God, you're not going to believe it. My dad, he checked himself out of the home. And I'm like,
wow.
Yeah. And I'm just like, hang on, roll that back. What? And he goes, yeah, he checked himself out of the nursing home while I was gone. He went to the grocery store. He bought razors and food. He's cooking. He's shaved himself clean. He's making a list of all the things he needs for his little room at the nursing home. And I'm like, what? It was so flabbergasting to me. When I got off the phone with him, he was ecstatic. And, and would happily tell anybody that now. But I literally drove around. I left the lab, and I got in my car, and I drove around like a zombie for 2 hours, because I was just kind of like, what? Yeah. I mean, as a scientist, you think you'll make some strides. You think you'll pull something off. You never kind of like, think you're going to just knock it out of the ballpark. And when that happened, I was dumbfounded. I mean, I had such extreme cognitive dissonance. I literally just drove around for 2 hours. And then I called my best friend and said, hey, so here's what just happened. And she said, wow, so 2 Nobel Prizes, jokingly. and it just, she goes, you don't sound really happy. And I was like, I guess I am, but it was such an impact. But that was an extreme case of really advanced cognitive decline, and then completely rolling it back. So if people don't have that, then it just boosts them, right? And I take this stuff. I take a lot of it, actually. And what happens is, one of the components that there are a couple of factors that I really kind of figured out there. So one of the components is your brain actually cleans itself through a little system called the glymphatic system, which is a subset of your lymphatic system. And your brain uses interstitial fluid and cerebral spinal fluid. And it's literally a hydrostatic pump. It pressure washes, if you will, your brain. The channel opens up while you're asleep, and then the interstitial and cerebral spinal fluids come in, and they wash your brain, take out the debris, and move it out. And typically little macrophages go in and nibble stuff up. But as you get older, you literally lose pressure. Your contractile force is lower, the energetics in all of your mitochondria are lower. And so one of the primary mitigating factors for that was to upregulate mitochondrial potential and increase contractile force in the lymphatic system and just get everything squished out. The other component was, over time, you've got this kind of constant declination in neural function as you get older, just because you're under environmental load, right? So if we lived, maybe 1,000 years ago and everything looked like the scene behind you guys, where it's all pristine and green, yeah, hello. As opposed to, I'm kind of the perfect example of what you'd normally get: beige box, in a hotel. But 1,000 years ago, it might not have been that big an issue, because we'd be outside, we'd be breathing clean air, we wouldn't be getting lambasted by environmental stressors all the time, EMFs, right? We wouldn't have that extra load. But because we do, we're kind of in a constant state of decline. And I always tell everybody, like, look, if you don't have Alzheimer's, it doesn't matter. You want this stuff, because it rolls back the aging in your brain, because it increases neuroplasticity. It increases neuronal output. So every day your hippocampus pumps out new neurons. But because neurons are super resource consumptive, like, your brain weighs basically 2 to 2.5% of your body mass, but it accounts for 20% of your oxygen consumption. So it is a resource consumptive little bugger. And because of that, your body, if you don't need the new neurons, every day it goes through a process called synaptic pruning and whacks them. And that said, if you put your brain under a new load, it'll actually cement the neurons into place and keep them. So one of the components of that serum is it increases the output rate of new neuronal production, like 2 to 3x. So then what I always tell people is, like, say week 3 after starting to take it, when your neuronal production kicks up, you want to start doing new tasks. So I will tell you, I have learned some of the most ridiculous and arcane and silly things, just because I know that you have to have a new neural pathway. If you go with some older neural pathway, your brain is very efficient, and it will take whatever primarily, myelinated path is, and run on that. But if you do something completely new, like juggling or learning a completely different instrument, like the djembe or some ridiculous thing like that, and I have done all of these things, you constantly put your brain under load, and at the end of the day, you end up with all these new neurons. So in an analogy for a vehicle, it's kind of like everybody starts out with like a 4-cylinder motor. Over time, it becomes kind of like this thing that's operating on 4 poorly functioning cylinders. But if you roll it the right way, you end up with a 6-cylinder engine, and then you keep going and you push it and you end up with an 8-cylinder engine. And I will say, just my own personal experience with this is, once you end up with a certain degree of density of new tasks that you've learned how to do, you start making connections that are seemingly disconnected for other people. They don't see the linkages, but when you reach a certain point, you're kind of like, if this, then this, then this, and you kind of go A, B, C, Q, and you start making these kind of intuitive leaps that you wouldn't otherwise make, because you have enough connectivity to do it. And so for me, that's been kind of the biggie, is because my gig is basically use my brain to solve puzzles for humanity, right? That's what I'm trying to do.
Yes.
Yeah, I'm
Let's
trying
go
to
there.
Okay, go for it.
So I've listened to a few podcasts that you've been on and super enjoy your work. You wrote a list on a whiteboard once.
I did. Seemingly a stream of consciousness. When I opened my lab, I guess it's been like 14 years ago. Yeah. I wrote on the board and I said, okay, what are the things that I want to solve, or at least if I can't solve them, make a dent in before I keel over. And so in order, it was aging, cancer, clean water, free energy, global warming, and superluminal travel. So faster than light travel. And I just wrote them on a board. And then, not shockingly, as the universe typically does, things started kind of lining up. You put the vibration out, and then everything starts to coalesce around that form, because everything is, as you guys know, everything is consciousness primarily, and then it becomes energetic, and then that aggregates and becomes material. So I mean, literally everything that surrounds us was in fact at some point a thought somewhere, and those things aggregate and they express. And so for me, when I put those things on the board, things started to coalesce in that order. And so I worked on aging first, and that was kind of the backbone. The carbon 60 stuff, which In my entire first cohort of animals, I was working on anti-inflammatory response, and I had this cohort of mice, which were genetically modified mice called P53s. And so basically, your P53 is a tumor suppressor gene. So these little guys are genetically modified, homozygous. So it's a knockout. So on both sides of the genetics, so that they will idiopathically present, which is the fancy medical term for spontaneous presentation of unknown origin of some sort of tumor. And we use them in oncology so we can test different things against it and see, if we introduce a chemotherapeutic or something like that, how much of an effect does it have? The benefit of using this type of mouse for me was that they have, because we've used, hundreds of thousands of them collectively in research science, they have insanely well-defined mortality curves. Like, plus or minus 2 weeks, exactly when those little guys are going to die. So I got this whole cohort of mice, and I was working on this anti-inflammatory thing, and they were supposed to be, done at 6 months. Well, 7 months came, then 8 months came, then 9 months came. And at the end of the day, there was a 93% extension on average across the entire cohort, which was, and I even reached out to the guys that I got them from, and they were like, well, that's not possible. And I was like, I know that's not possible. I don't understand what the hell is going on. And so after that, I thought, well, damn, that's kind of a pretty intense indication, 93% extension in lifespan, which was cool because it was actually a replication of another experiment in effect that had been done by a research group in Paris by a guy named Fatih Moussa, who's a researcher over there. And what they found is they did the same thing with the same base component, and they ended up with a 90% extension in lifespan. And I remember when I saw that paper, my dad, actually, he was a professor, and he sent me the paper, and I read the paper and I thought, bullshit, nah. I was kind of, admittedly sort of academically jerky. I was a little incredulous about it. Like, that can't be 5% extension, 10% extension. Sure, I could buy that, but a 90%, and then effectively I ended up recreating that experiment, and I got a 93% extension. And then I kind of thought, well, statistically, a 3% variance is a little too tight for that to be just some random thing. So then that was kind of like the aging thing hit on the board. And when I started looking at it, one of the super bizarre things about that entire experience was when the first rat or the first mouse died, I did a necropsy, which is basically you open them up, and it's kind of akin to an autopsy, right? So I opened them up and I went through everything, and there were no tumors. And I thought, well, that can't be right. These guys, they're literally designed to die from tumor burden. And it had died from a femoral hemorrhage. And I thought, okay, I must just suck at veterinary pathology. So I'm going to, hire a vet pathologist to do a full histological workup and do a necropsy. So the next time a mouse died, I put it on ice, overnighted it to a vet pathologist, and had a full histological workup. Same thing, no tumors. And I thought, well, that makes no sense. And I kept doing it. Mm-hmm. I did it through the entire cohort. And there were occasionally little bitty tiny tumors, but that's not why they died. They all died from old age. And there was one that I had actually screwed up the freezing process on when I shipped it. So that one I can't really count in the cohort. But literally every single other mouse, it either had zero tumors or had, some minor presentation, but it wasn't causal in terms of its death. And so at the end of the day, I was like, oh my God, the implications for oncology are just insane. And I had literally, it was like just stumbling upon this. So then that was like item 2 on the board, cancer, like with a big dent. And I was like, well, damn, I need to pull this thread. And the thing is, I think as a scientist, right, your job is supposed to be finding the truth. It's no different than spiritual endeavors, right? At the end of the day, the last analysis, your job is to elucidate truth. Period. Dot. Is at least insofar as I think it. A lot of people might think it's to get a paycheck from Pfizer. Not me. Slightly different approach. So I pull the thread, and I used to tell my students, because I taught senior biochem at a university, and I used to tell my students that science is a point on a line, and the best thing I can possibly tell you is going to seem like idiocy 1,000 years from now. If we as a species and a society make it that far, it'll just seem like lunacy. And I always joke with cancer right now, it's kind of like, they look at it and go like, your leg is wet, we must amputate. There is no other.
Oh my God.
And unfortunately, and there are a lot of really good researchers doing a lot of things, but there's kind of this huge gap in translational medicine from guys like me who are the research nerds, and then the guys who are actually the clinicians where they get to apply this stuff. And so, I kind of try and bridge that gap, but it was the whole process was enough of like, oh snap, I better pull the thread. And the other thing as scientists, and I would lecture about this before, is you're always told to look at parameters, right? And everything you have statistical anomalies that are outliers. Well, what do you do with an outlier? Well, you discard it. Usually when you're doing a statistical analysis, you'll throw that out, or you'll just factor it into your calculations, but it kind of goes out in the wash. Effectively, it's kind of like if you drop a ball 1,000 times and 999 times it falls to the ground, and one time it just hovers in the air. Well, the way we're taught to do it is to disregard it as, anomalous statistically and just chunk it out. But if you think about that, that's really the crux of like, hang on, why is this ball floating? What just happened? Like you should genuinely kind of pull the thread and try and go for the heart of the matter. And it's not incentivized. Actually, in fact, it's disincentivized because when you do that, people think of you as a complete wackadoo loon. And that's kind of a problem scientifically, right? Because it puts you inside this little box where you limit the progression of technology and science as a whole because you're scared to go outside of it and do anything different. And not to digress too much, but when I was younger, my dad is a really freakishly brilliant guy. And, by the numbers, like 180 IQ, one of the smartest cats probably on the planet. And I asked him one time, I was like, how do you do what you do? Like, it's unfathomably sharp, And so he sent me a book, and it was kind of this book about how to enhance your genius. And one of the things that was truly pivotal for me was, and this was kind of like a Stoic philosophy, almost sort of a Marcus Aurelius kind of thing. It basically said, you're not going to be harmed by other people's words. So in this case, go into some large, crowded public place and make loud animal sounds. And I was like, what? Well, okay. And so I did. I went to the Barnes and Noble in Westlake in Austin, where I live, and I went in and I kind of looked around and went, caw, caw, and started making loud animal sounds. And sure enough, people are like, what? Like looking at me like I'm crazy. And then I stopped and I went about my business, and I was like, oh my gosh, I'm not affected, right? Like, I can seem like a complete jackass. And truly, if you're going to push the bounds of any field of endeavor, you are going to seem like kind of a nutter. You're going to appear to be kind of a moron because your ideas are going to be so far outside of the normal parameters, just by definition, right? If you are kind of trying to operate in the 1 in a million range, you're pushing the bounds. And the people who are inside the parameters are going to think, oh, that's stupid. That's a waste of time. It's laughable. And you'll be met with scorn. And then eventually, if the ideas are vetted out over time, then you're like, everybody kind of lauds it as like, wow, that was a brilliant approach. And but there has to be a certain degree of tenacity and a desire to elucidate just whatever the truth is, as bizarre as it seems. You have to be willing to find the thread, pull the thread, and see it to its conclusion. And in general, science, you never really actually see it to its conclusion. Like I said, it's a point on a line. Like all the stuff I'm doing that I think is really kind of fancy and cool. Hopefully, in 10 or 15 years, somebody new will come along that makes it seem obsolete or picks up the ball and carries it forward. Actually with the carbon 60, I eventually filed a patent on ameliorating the effects of cancer and stopping metastasis using a certain combination. Technically, it's called lipofullerenic saccharide conjugate. So it's basically sugars bound to fullerenes and then some other things. And I called the guy who actually got the Nobel Prize for carbon 60, and he was a super nice guy. We became friends after that, named Bob Curl. He was a professor at Rice and like a genuinely kind man. And I reached out to him and I sent him the patent, and I never expected to hear anything. But my take was, if I'm, an older scientist and I've done something, and obviously he was, it was very well received. I mean, he got a Nobel Prize for it. But if somebody was going to take that and push the ball forward down the field and do something monumental with it, I would want to know. So I was kind of, just trying to be the change I want to see. So I reached out to him, sent him the patent. And shockingly, he reached back out to me, and we kind of started a dialogue. And I said, look, I am fully aware that I'm standing on the shoulders of giants. And I just wanted to say thank you, because I genuinely feel like this will help millions of people. I can actually overcome the hurdles of getting it out to the, the public en masse. But I think it'll make a big difference. And I just wanted to say thanks. Like, I would not have been able to do what I'm doing without you, doing the work that you did and kind of pioneering this component of it. And it was really actually beautiful. He was genuinely very thankful and kind about it. And we, then I would go down and see him and hang out, with him. And he was a really fascinating guy, and a hell of a chemist. Like, actually, I have an admiration for people who are just very adept at whatever they do, whether it's arts or sciences. And this guy was great.
So you have the C60 in your formulas?
Yeah, I do. Not all of them, but a lot of them. I mean, there are other things. So some of them I'll use, and it gets a lot of bad press, but if you use it properly, it's like anything, Paracelsus said, the dose makes the poison, right? So sometimes you use things like methylene blue is a compound I use. It's similar. It's an electron donor and an electron acceptor, and you can use it to modulate neural function, mitochondrial function. You can do a lot of things with it. Personally, I don't think it's great in high doses, but I actually use it as in one of my formulations as a contrast agent, so your body can more readily perceive where things are broken.
Cool.
And yeah, well, it just like it's a contrast agent, so you can see like, oh, this mitochondria doesn't function as well as this, and when your body perceives that, it triggers a thing called mitophagy, whacks the mitochondria and replaces it. And so at the end of the day, you use compounds like that or like carbon 60. I'm kind of agnostic. A lot of people think that just because I got a lot of press for doing the carbon 60 stuff, a lot of people think like, oh, he's a C60 guy. I'm really not. I hold out firm hope that at some point something will come along that's way the heck better.
Cool.
It's a process.
Ian, you've invented many things. We've gone deep on a few, but if we can get like rapid fire for a moment,
Sure.
There's inhale hydration, which we're about to chug, because this stuff is magic dust. We can go deep on this in a minute. You've also invented concrete that actually like sucks carbon out of the atmosphere. You have a cancer serum, as you've been sort of talking a little bit about the pathway to discovery on that.
Right.
Ozone. Okay, super cool, because ozone is O3 and it's super powerful for immune health, but you've figured out how to make it more stable. So you have an ozonated oil that we should absolutely start traveling with. And I believe that one is connected to Nikola Tesla. And historically, can you talk about that?
Yeah, that one. Okay, so every now and then somebody comes along and you just read their work and you're like, wow, that dude is sharp. And so when I got reached out to by a company initially to develop this ozone thing, and they asked me if you could replace autohemotherapy in a pill. And autohemotherapy is where you pull your blood out, you introduce direct ozone, your blood flashes from kind of a dark red to this beautiful bright cherry red. And then you reintroduce it, and it triggers a thing called an ozonide cascade, which kind of upregulates your mitochondria, downregulates inflammatory response, and you feel really good. And a lot of people go in and they do it, but it's, it takes a while. You have to have your blood drawn. It's a couple hours at a time, a couple $100 usually on the low end. And, you've got to go to a medical clinic for it. And it's kind of a pain in the ass. And so these guys reached out and asked if I could do that. And I just said, no, probably not. I don't actually think that's possible, but it was a gig, and that was kind of my job, was like, okay, well, I'll try, so I said, yeah, sure. I'll see what I can do. I probably won't be able to do it, but I'll see what I can do. So I went back to kind of get my educational resourcing up on ozone and read, Sylvia Menendez work, and from Cuba, who was a great researcher on it. And then there's a couple of guys, Frank Schallenberger in the US. I read all Frank Schallenberger stuff. And I just tried to get my basic education up on what is this? How does it function? And then I started looking like, okay, where did this come from historically? And so I went back, and Nikola Tesla had actually developed the Tesla ozonated oil company, or ozonated olive oil company, in the early 1900s. And I thought, well, that's interesting. So I started reading his stuff. And Tesla was doing this thing where nowadays people just take oil and they force feed ozone through it with a thing called a venturi, and it cycles through and it reaches kind of a max concentration. It stabilizes a little bit, and they use that as ozonated oil, put it in capsules, and it definitely has an effect. But Tesla was doing this weird thing where instead of like nowadays it's a week and a half to 2 week process, his process was 8 weeks, and which struck me as a little odd. And everybody just thought it was some kooky Tesla thing that he was doing. But he had these long beds that he would fill with oil that had electrical wires under them that he would then light up and create long magnetic field beds. And I started thinking, well, wait, what is going on? Then I thought, oh my gosh, ozone is a polar molecule. So if you lock these things with field beds, everything lines up in single file order. So you have it side by side. And everybody had, kind of purportedly said that his ozonated oil was like the best thing ever. You could put it on a wound and it would wipe out all the infections. And sure enough, he wasn't nuts. The reason he took 8 weeks to do it is because he kept everything in the highest concentration, because it was all lined up in single file and little lines next to one another because of the field expression. And I thought, damn, this guy is like sharp as a fucking tack. And it was like wild for me to read his stuff, because I'm like, oh my God, really smart. And so then I thought, okay, well, maybe I can do that. So I did that. And then I thought, well, that was 100 years ago. We've had a lot of tech since then. I mean, Tesla actually imagined a lot of things and could conceptualize a lot of things that the world just literally didn't have the technology to make manifest at that point. And so, now we have lasers and plasma, and all kinds of stuff. And so I thought, okay, I've got 100 years of toys to play with. Let's see what I can do. Maybe I can even do something better. So I kind of bolstered up the strength of the ozone in the oils, and it was good. And then I figured out, okay, I can get it really amped up through this and this and this, and I did that. But then the problem was, after about like 3 hours, it would kind of start to lose coherence, and it would just go away. And I thought, well, that's not going to work. So then I started thinking, well, okay, what else did Tesla think about? And Tesla actually had kind of envisioned lasers and how laser optics would work. And so I started thinking, so what is a hologram? Basically, a hologram is you have an object, you use coherent light, you have another reference beam coming in, you collect the scatter onto a plate. And, if you look at a hologram, like a holographic plate, you take one beam, you separate it into two pieces, you have a reference beam and an incidence beam, you catch the scatter, and you collectively imprint an interference pattern, which is just basically all of the waves coming together locked in a certain frame. What most people don't realize is if you take one of those holographic plates and you throw it on the ground and shatter it, every single piece of that's broken down to a single molecule, like a single, silicon dioxide, little bitty crystal, little tetrahedral crystal, contains all of the information of that entire waveform. And you can actually fire a laser through it and recreate that interference pattern down to photonic scale. So you're operating at a more than subatomic level. You can recreate a perfect copy of that interference pattern. So I thought, okay, I'm playing with oil as a carrier here. What if I quantize all of these things to get the expression of force up, and then I lock it with a laser, like basically turn this gel into a hologram? And I thought, well, holographic plates are glass. People think of glass as solid, but it's really not. It's an amorphous solid. So if you take 1,000 years and you look at a window pane, it's actually going to sink down, like the old cathedrals in Europe. The base is a bit wider because it's really more like a soap bubble, just in a time scale that humans can't perceive. And so it's kind of slowly dropping down. And so I thought, okay, so I've got super fast pulse laser, glass, and oil. Two of those are actually a lot closer in time scale, the glass and the oil, as opposed to the super fast pulse lasers. So I thought, okay, let me see if I can turn this into a holographic gel. And I did. And it actually worked, and it stabilized it. And so part of the process there, to kind of go down the rabbit hole, is when you have a molecule, it's information, right? A molecule contains a certain amount of information and can express that information via its interaction with other things. And we always think of a molecule as this one little bit, right? And so there was a fellow named de Broglie who got a Nobel Prize in 1924, who's kind of one of the pioneers of quantum physics for figuring out emissive waveforms and like what the wavelength is going to be from something. And basically, back in the day, he said, okay, I've got this atom or this molecule, and it's got an electron orbital shell that's coming off with a certain frequency, and that's how I can tell what it is, which is how a lot of spectroscopy, where we analyze compounds today, comes from, like, is understanding that certain things shoot off a certain emissive wavelength, right? And that's how you can drill down and see what something is made of. But what it doesn't take into account, that we've kind of elucidated over the past 100 years, is that we just think of these things as random, and typically they are, but electrons actually have spin. Everything in nature has spin. It has a rotation. And if you quantize that and get them all moving in the same direction at the same rate at the same time, it's kind of the difference between a light bulb and a laser, right? So you can have the same number of emissive photons coming off a light bulb, and it'll maybe warm a hot dog. But if you have it coming off in a coherent form from a laser, it'll punch a hole through steel. Right. So the amount of power that you get out directly correlates with how coherent the waveform is. Interestingly, consciousness is exactly the same. The higher your consciousness, the more things you can do, the more things you can affect and change. And so in looking at that, it's kind of a good analogy is if you look at the solar system and you said all of the energy in our solar system is because of the planets revolving around the sun. That's not really true, but that's what de Broglie's equations are basically correlating with, is that, you have these things revolving around the outside. What it does not take into account is the confined rotational inertia, right? Or the angular momentum of the planets spinning on their axes. That's actually a huge source of energy. And so if you kind of drill that down at a microscopic level, you say, okay, well, what if I get all this stuff functioning at the same rate at the same time? What happens to the power output? And it goes up, and it goes up a ton, right? That's the light bulb laser analogy. And so that's what I did with, the ozonated oil, is I got everything moving at the same rate, and I used acoustic drivers and plasma drivers. And it's this kind of ridiculously bizarre contraption with lasers firing at, all kinds of stuff through dichroic beam splitters. And at the end of the day, though, it worked. Tesla just didn't have the tools that, I have no doubt that cat could have absolutely figured out how to do something like this, but he just didn't have the tools, right? The rest of the world had not caught up to him. And so I have a toolkit in my wackadoodle lab where, and if you guys have been there, it's kind of like, it's sort of like Willy Wonka for science.
Oh, yeah.
I know your lab is really quite something, and we really enjoyed being there. And some of this equipment you had there is like, wow, what's he doing with that?
Yeah.
And now you've moved to another lab, right?
Yeah, actually, yeah. And it's much larger. And we actually got booted out of our previous lab. They decided to annex the space at the college it was at, annex the space and use it. So we had to move. So I thought, okay, I don't want to get booted out of another space, because we had been there for a dozen years. And, it was that was home for a long time. So I bought a big building, and we've been adding to it and putting in all sorts of stuff. Because I'm lucky in that, my lab, I've got a whole segment where we do, mechanical things. We have metal lathes and CNC machines and, metal mills and all that kind of stuff. And then, we do welding. And because when I have some crazy idea and I'm like, hey, what about concrete? And we do the carbon negative concrete. We do something different. Well, oftentimes I will need some new device, because quite frequently it just doesn't exist. And so I'm like, well, how do you fix that? Lots of 3D printers, lots of welders, lots of technicians, and you build it, right? In the absence of something, you build it. So that's what I've been doing.
So Ian, we have about 15 minutes before you have a hard exit.
Oh,
I want to.
Wow.
Yeah. Time flies.
Time flies.
Time is speeding up. We can talk about that in a minute. We want to, first of all, you're going to actually be in Shasta with us in July.
Am. I get to see you guys.
There's an opportunity for people in our community to actually work with you. Can you talk a bit about that?
Yeah, actually, so the reason I'm in a hotel right now is I'm in Los Angeles training a bunch of doctors on a laser stem cell procedure. And stem cells, I will say, is a loose approximation. That's kind of what the most common thought is. So basically, we take a person's whole blood, we extract it, and say typically about 120 milliliters, and then we spin it down into PRP. And pretty much everybody is familiar with platelet-rich plasma, right? So you separate the plasma from the blood, and you typically just inject it back in a joint or something like that. Well, turns out if you take lasers and you modulate them, you can get all these kind of wild, super beneficial effects. And so what I do is I take a cryogenic shock. So your plasma has all of these dormant factors that are asleep, and we will typically call them very small embryonic-like stem cells, V cells. And the thing that's nifty about those is they're very, very tiny. So they're a fraction of the size of a normal stem cell, which is great because it allows them to pass the blood-brain barrier, to move to any point in your body. And they're also pluripotent, which is if you work with, say, mesenchymal stem cells, which is kind of the common thing, they're not able to differentiate into all of the different systems in your body. Pluripotent stem cells can differentiate into anything other than a germ cell, like sperm or an egg. But they're capable of regenerating literally everything. And so that was kind of fascinating to me. So I thought, this is something I should play with, because in terms of regenerative medicine, like with Alzheimer's, I can do a lot to really kind of ameliorate the issue and to roll things back a bit. But if somebody really has damage, if they've had a traumatic brain injury, or they're just really so occluded that I can't make as big a dent as I want to, then I kind of ratchet up to this. And so I can structurally rebuild things. It's an additive system, right? It's going to, like in the case of my dad, who was completely reluctant to do this, but I finally got him to do it by virtue of his cardiologist going, "Oh my God, he has access to that? That's awesome. You should totally do that." Telling my dad that. To which literally my dad, you could audibly hear him go, "Oh." Because no matter who you are and what you do, you're still somebody's kid, right? Like Shakespeare was at some point in somebody's 7th grade English class. Like, it doesn't matter who you are. It's Billy. What the hell does he know? Like you're always somebody's kid. So with my dad, I finally convinced him to do this, laser stem cell procedure, and his ejection fraction, he has congestive heart failure, or I should say had congestive heart failure. So his ejection fraction was at 21. Wow. And now his ejection fraction is at 36. And so massive shift. And I got him off a thing called milrinone, which was a pump system they had used to directly pump a compound into his heart to increase contractile function. So he could basically kind of make it through the day, because he just, with an ejection fraction of 21, you're sucking wind. Your life is pretty miserable. And so they use this thing called milrinone to make you stronger. So he did that, but the downside is it shortens your lifespan. And then they also had him on a thing called amiodarone, which is, if you read the little paper in the insert, and I always do, one of the side effects is sudden death. So I wasn't a big fan of that. and so anyway, long story short, I finally got him to do this, and we massively changed his heart, right? It started rebuilding his heart, as is evidenced by the huge shift in ejection fraction. And it's continuing to get better and better and better. But that's by virtue of taking these factors out and turning them on, waking them up. And you wake them up with a thing called a hormetic stress. Kind of basically the idea of hormesis is what doesn't kill you makes you stronger. Kind of like, the shock activates things. So I use a cryogenic shock followed by a photonic shock, wake these guys up. Then I quantize them. And this is where it's kind of interesting. I quantize them so that all of the tone, if you will, is linked to the tone coming from the laser. And so it's the frequency bands. I use a 4-channel frequency, so I can, different frequencies penetrate to different depths. And so I use, say, 635 nanometers, which gets just a couple of millimeters of penetration, and then 810, 980, 1064 to go deeper and deeper and deeper. So you're looking at, technically the term would be stereoscopic deposition of cells across a tissue and organ system. So I'm just figuring out how I can kind of fill the area that's broken up at certain depths. And so I quantize the cells, and then I move them, I reintroduce them with an IV. And when they're flowing through your circulatory system, if you put the tone from the laser on a certain spot, it actually moves those things to that locus. So they all situate in that particular region. And that's how you get such a big healing effect. The other thing that's kind of magic about it is those V cells are day zero. So at the end of your DNA, you have these things that are called telomeres. And the telomeres, it's just a repeating sequence. And it's kind of like the aglet on your shoelace, like the little band around the end of your shoelace that keeps it from being frayed. And every time your cells replicate, you lose 25 to 250 base pairs of these. And so the telomeres go away. And in the case of the V cells, there's no telomeric degradation. So they're day zero stem cells. So it's kind of as if you had your own stem cells from your own body from the very first day you were born, and then could just reintroduce those. And that's a huge benefit. And I'm a little bit of a stalwart because most everybody thinks just stem cells from another source are fine in your body. And I would posit, and I could be wrong, but I would posit that in another 10 to 15 years, people are going to realize, oh my gosh, nature actually figured out how to encode storage with simple electron spin, right? Mm-hmm. And because of that, your DNA resonates at a specific rate and emits a certain frequency. That's the frequency that you would call you. And when you use something that's genetically coded to that, it's like having an OEM part, right? Your bumper gets knocked off of your car. You don't just randomly go out and buy a bumper from a truck and wedge it on and say, got a new bumper. But fundamentally, that's kind of what happens in medicine right now is you go out and you play with stem cells and you're like, oh, look, a bumper. You put it on. Sure, it is in fact a bumper, but we haven't expressed the granularity to see what does and does not work, right? You can get a replacement and it's going to work better than having nothing, but it's absolutely not as efficacious as if you have the original bumper from the original manufacturer that's perfectly attuned to your vehicle. And that's kind of my supposition with the cells is if you can get something that's autologous from your own body and then spool it up so that you can redirect it where you need it to go in your body, that's the prime mover. That's exactly what you want, is you want something that's from you and expresses your own resonant field. And then that will actually help. And that's what I've been seeing is I think the results that we've been able to elicit are great. I mean, they, reversal of blindness, all sorts of conditions, like really surprisingly profound things. And I think it's by virtue of just having a kind of a respect for nature and going, it's probably a better system than we have. There's a lot of in humanity as a whole. I'm not just going to say in the sciences. In humanity as a whole, there's this kind of crazy degree of hubris of thinking, we are so distinct and separate from nature. We're so smart. We have all this stuff. Yeah, maybe not. Nature has generally figured it out, like the cloud, right? We store data on the cloud. If you read Rupert Sheldrake's work, it's very clear that the morphogenic field is the cloud, right?
He has that, that's his first thing he wanted to ask you about was the morphic field of humanity.
Yeah.
So,
we're gonna have to do a part 2 on this.
We're gonna do a part 2, science and spirituality, because when we went down, we visited you in Tulsa, and our dear friend Opal went with us, and and she was like, telling us that you spoke with her about your childhood, and she was like, most scientists get into spirituality as part of their journey, but with Ian, it's the other way around. You started out extremely spiritual, and you developed yourself as a scientist.
Yeah, and I kind of, it's funny to me because I kind of feel like I woke up sort of, science is almost like the religion of the modern era, right? It's the way we define things, because if I look at something that just fell down off a shelf and I go, oh my gosh, Zeus and Hera, they've pushed it off. Well, yeah, that's one way to explain it. And another way would be to say, oh, something bumped it. Another way would be to say, well, there was a force and it expressed angular momentum, and it kind of hit a point of leverage. And I mean, you can define things in scientific terms, but you can also define things in religious terms or spiritual terms.
The synchronicity field of the entire universe did it. Angular momentum.
Right. I mean, there's lots of different ways, but I kind of feel like when I woke up, I was like, oh, okay, well, I'm going to go into this field. And for me, it really is. It's like just sort of being anointed into the priesthood of a particular religion. And it's the religion of the day, right? It's how we express things. And I'm happy to express things like that. But a lot of the issues that are plaguing humanity as a whole, you can't fix them with widgets. they're energetic. And it's like I said, everything starts out as a thought first, and before that everything is just pure consciousness. Before that it's just awareness, and those things are gradations, and they kind of move in layers out, and it becomes apparent and tangible once it's moved beyond the certain threshold that people are capable of perceiving. Prior to that, it's very different. But that's really the root of a lot of the issues. I mean, you guys know this. I can energetically, there are things that I can do, and I talk about it because I can do it repeatably every time. And it throws people a lot. And I usually couch it in the sense of, say, quantum biology, right? If I change the color of something or the flavor of something, or, and I do that all the time. And I do it with people in Zoom calls on the other side of the planet. And I can express it in terms of quantum biological effects. And I've done, tons of double-blind placebo-controlled trials elucidating quantum biological effects where we upregulate ATP on the other side of the world, and, and can do it well beyond statistical significance. That's cool and all, but really what that tells you is consciousness is a field that is pervasive. It's not temporal, right? Mm-hmm. It works, irrespective of time or distance. Everything and everyone is connected. And that's the reality. And so for a lot of the things that I'm trying to bring forward to just sort of help move us down the field a little bit, my true intent is from a standpoint of consciousness and awareness. Like, okay, what can I do to help? What do we need? And truly, and when we kind of drill down on science and spirituality, for me, that was a process, right? I was very spiritual early on. Then I immersed myself in the sciences, and then kind of went through a process of cracking open like a big egg. And when that happened, my perception of everything shifted, and my ability to actually be a more fundamentally beneficial creature went up many fold, because my intent was different. The source of where I was coming from was different. And so, yeah, I mean, it's true. I kind of evolved in one direction, but I think ultimately it's made me a better tool to be able to help, which is, at the end of the day, that's really kind of it. I mean, I had the foresight to catch it early on when I wrote my list of things I wanted to do before I keel over. And honestly, I've been very lucky in that as my consciousness expanded, everything lined up. I don't really think that was coincidence.
Yeah, it's not luck. But anyway, I mean, after our experiences with you, when you worked on me, within about 5 minutes, I could feel the difference. And so we immediately, when we got together, we said, how can we bring iron to our community? And so we were really chuffed and excited when you said yes, that you would come to Shasta and share this. So
I've got to say,
you're going to bring a bunch of tools, right?
Yeah, I'm happy to do it. And I will say, if you don't mind me saying this, I mean, it's your community, so I'm sure everyone is kind of aware of it. Working on you was actually one of the most interesting things I've ever done, because what I do now is my toolbox is a lot bigger and filled with a lot more tools than it used to be prior to my consciousness kind of shifting. And so I always feel a person's subtle form when I'm working on them and kind of redirecting things. And when I was working on your sinuses, I started moving, and I don't generally tell people what I'm doing, but yours was such a stark contrast. People feel like people generally until you. When I started working on your sinus cavity and I was feeling into it, you had a snout. And I had never felt anything like that. And I was like, what? And I started feeling around. I was like, oh my God, that's a snout. And then I realized, that's a dragon. Mm-hmm. Why is there a dragon here? And, and I thought, like, kind of the internal dialogue was, well, damn it, I don't know a damn thing about dragon sinuses. What the hell am I going to do this? So I kind of had to very quickly download, like, how does a dragon sinus work? What do you need to do? And then, I was able to, kind of complete the task. And then I shared with you after the fact that, hey, it's a little peculiar here, but your astral form and your subtle bodies, they don't really line up with your visible shell right now. You kind of have a snout, which was not a shock to you guys, but it was.
You blew my mind, Ian, because you didn't know this, but Prageet. Okay, so in Stargate world, our soul has the ability to subdivide into 12 aspects, all experiencing life in another dimensional reality. And Prageet has an aspect in the dragon realm, and he channels this dragon.
Yeah. Well, I will tell you. Okay, so I, did my homework and kind of tapped in to see what was going on after the fact. Sure enough, the consciousness, the weight of the consciousness from that aspect, from a dragon, has so much more oomph that when you channel that, it creates a resonance. It's like ringing a bell. And that resonance is so strong from that higher point of consciousness, in terms of higher density of consciousness, that it literally modulated your astral form to be a dragon. And so, though you don't visibly see it, when I started feeling it, it really did. I mean, it was jarring to me because I was like, "Whoa, hey, ho there, what is that?" And it's, that's what it is that aspect has so much more oomph and so much more knowledge and so much more power than what we typically see, that just the fact that you channel it, it's kind of like dyeing a cloth over and over. It's actually modulated your form. And I would posit, based on what I've seen in the world of, how physical things manifest, if you lived another couple hundred years, you wouldn't look like you look now. You would actually start to elongate a bit.
Well, I channel other entities as well, so I don't know how they affect it. But when I do channel run, it's like, as I start to do it, I feel like this whole and my body moves. I feel like wings happening, and it's really quite something.
We call it a multidimensional overlay.
Yeah. I mean, it's
amazing. And that is very much in keeping with what, shockingly, I felt was these layers don't line up like normal layers. Because really, like, I've done hundreds of these, and I had never felt anything like that. It was remarkable. Obviously, I remarked about it because I was kind of like, "Hey, by the way."
Well, it's going to be really interesting to see what you see with some of our community, because many of them are really connected in different ways. So
that's beautiful to me. I mean, it really is. That's kind of that's the fun part of doing this sort of work, is, where the science and the spirituality integrate. It's brilliant.
So, Ian, we're stoked to have our part 2 conversation with you.
Oh my! I cannot believe that. Yeah, we've zinged by an hour.
Yeah. Let's quickly, what is super oxygenated water?
So, okay, water normally has 5 to 8 parts per million oxygen, and that when we can it, it's at 180 parts per million, and we kind of take out all of the airspace, press the lid on, squeeze water out, so it basically forms a vacuum, so it can't be delocalized and kind of disassociate and float out into the air. When you crack the lid, those cans are like a rock. I mean, they feel like an iron pipe. And it's because there's so much pressure in there. So when you crack the lid, a lot of the oxygen races out, and it drops down to about 100 parts per million. And then over about an hour, it drops to about 57. But I literally just finished our clinical trial, so it's going to be logged on FDA.gov shortly. But the clinical trial with that, we proved that it decreases your heart rate and increases your oxygen saturation. So basically, the idea for me was to decrease cardiac loading, take the strain off the heart on the physical side. And the side that's really kind of my big thing with that is I use it for cancer patients, because cancer is an anaerobic process, just meaning without oxygen. And so if you can put people in a hyperbaric chamber, you get really good effects. It should be like a second line or a third line therapy, for people who are dealing with cancer. But it's a real pain in the ass to get people to be able to go into a hyperbaric chamber all the time. So rather than put them in the can, I figured, hey, what about putting the can in them? And so I compress that stuff and set it up, and it works like a champ. So if you increase oxygen saturation, you can decrease proliferation rates. And so cancer functions via, the anaerobic glycolysis. So if you put a ton of oxygen in, you just kind of pump the brakes on its capacity.
I guess it's time.
Yeah. All right. Well, we will loop back. I'll give a more thorough explanation on that when we regroup. But look, guys, it was great to see you. I very much care about both of you. I'm really happy to see you again.
Yeah, you as well, Ian. And to me, there is a super benevolence to the level of consciousness you're operating at and the work that you're doing in the world. And I want to thank you for that. You really care.
Cool beans. All right. Peace out, guys. Bye.
All right. We'll see you next time. Have
Okay.
a beautiful day.
Much love
You
and
guys
happy
too.
travels.
Thanks, guys.
Bye-bye.
Bye.